All right, guys, this is going to be the last video for chapter 8. I'm looking at confidence intervals for a mean. So instead of looking at proportions, instead of looking at percentages, we're looking at means and how to do this. So same as normal, I'm going to kind of talk about some highlights in this video. And then in class, we'll kind of go through some of the actual specifics, look through some of the examples and all that good stuff. So first thing, what is the formula for the confidence interval for population mean? We have X bar plus or minus your t critical value. We talked about the t. This is your test statistic. And we talked about the difference between the t critical and the z. Right, when you're estimating about the population, we're going to use a t. So that's where that comes from. And sx, which is your standard deviation over the square root of n. And so this right here, this sx of the square root of n, this is in your standard error. So the SE of x bar, and we talked about standard error in the last video as well. As part of the difference between when you know population information, when you don't, or when you're estimating it. So that's what this is. And this describes how far x bar will be typically from mu in repeated SRSs of size n. All right, so what are the conditions we got to check? So the first one, randomization. This allows us to extrapolate to the greater population. We have the 10% condition, so n needs to be less than or equal to 1/10 of big N. This controls slash limits variability by looking at independence. And then you have your normality check. We have a couple things that we can do. So it could be given in the problem. It could be that you have to graph the data. Or last one, you have a large sample where n is at least 30. And so then you can use CLT. One little thing is if you know your data is strongly skewed, do not use the t-distribution. But again, it's going to go back into this checking your conditions before you even attack these problems. So here, if you look at this first problem, this is one of those ones where you got to graph it, because here I've given you some information, but you don't know anything about the distribution, whether it's normal. So you'd have to graph this first. So try that out. It's a good refresher on how to use a calculator to graph histograms, or a box plot, or a stem and leaf plot, even if you want to do one of those. Take a look and see if it's approximately normal, and see if you can calculate the confidence interval from the formula I gave you above. So take a couple minutes, see if you can figure that out. And again, we'll go over this in class. So can you use your calculator to do this? Yes, you can. But again, you got to do some setup. You got to label everything. Make sure you know what you're talking about before you use it. So yes, just set the problem up. And then you go menu. We kind of talked about this in the last video, statistics, confidence intervals. Okay. Make sure you do know the equations though, because for multiple choice questions, it may be useful to know the equation. So again, I want to spend a lot of time in class going over these problems together. So I'm going to skip this problem right now. We'll do all 4 steps together. That's going to lead to the last part of this video, last part of these notes. So how do we approximate sample size when planning a confidence interval for the mean? So if I use my equation from the first page of these notes here, we have margin of error equals t critical times standard deviation of x over the square root of n. Okay. And if we try to, if I divide by if I try to solve for n here, right? So if I divide by t critical on both sides, you get the sx over root n, right? And if I try to kind of isolate n, now the thing is that once you look at your t distribution, and we're going to look at this chart together in class, and we probably already have at this point, your t distribution is based on n. So the only issue is now, even when I multiply by root n on both sides, and then kind of move everything around, what you're going to end up having is you're going to have n equals, once you get to the end, sx squared, if I squared everything, divided by me over t critical squared. Now the issue is that when you start looking at the t distribution, it's based on degrees of freedom. Which we'll talk about in class at this point. And so you need to know n in order to use it. So because of that, we can't really use the t distribution in order to approximate sample size. So what we can do is kind of come up with an approximate for this value by using the z critical, even though it's not going to be the exact same. It will be something somewhat similar, and it'll give us a good estimate of what we need to do. So then we go back and we go me equals z critical. If I change it from t critical to z critical to sigma over the square root of n, and try see if you can solve for n on your own. Okay, and you should get that n equals sigma squared divided by me over z critical squared. Okay, and see if we can use that equation to see if we can come up with the n for this problem. So, and again, a little note, when you're finding sample size, always round up. Okay. So that's it for this video. That's going to be the end of all these notes for chapter 8. As always, if you guys have questions, let me know. And like I said before, we'll go through a lot of the questions in more detail in class. But in the meantime, have a great rest of your day.